Welcome, stargazers. Could you at any point trust it? Picture a heavenly occasion so colossal that it makes concealed regions on Earth observable even without, truth be told, attempting to conceal. That is the presentation we might be close to the problematic edge of finding in the Orion gathering of stars. The star Betelgeuse is acting bafflingly, insinuating a coming infinite blast, an impact that will enlighten our sky like never before. Yet, when will Betelgeuse go supernova and what will it look like? According to scientists, what secrets might this great occasion uncover? Go along with us as we bounce profound into the subtleties of what's really going on with Betelgeuse and the impact it could have on Earth, and perhaps on the entire nearby planetary gathering. Saw as about 650 light-years from Earth in the Orion constellation, Betelgeuse isn't just any typical star. It's a red supergiant, maybe one of the most shining stars known to us, glowing with a brightness in excess of multiple times that of our Sun. However, why does this red giant matter to us so much? Well, Betelgeuse stands apart not only for its brilliance but also for its history and significance in human culture. Named after the Arabic expression Yad al-Jawza, which implies the hand of Orion, Betelgeuse has been observed and recorded by ancient civilizations for many years. It has been a guide for explorers and a source of wonder for stargazers, with its reddish hue distinguishing it from other stars in the Orion constellation. Could you at any point imagine a single star dwarfing our entire planetary system? To give some perspective on the sheer size of Betelgeuse, if it replaced our Sun, its edges would extend all the way to Jupiter. How might a single star achieve such colossal dimensions? At 10 million years old, it's much younger than our 5-billion-year-old Sun. However, Betelgeuse's massive size means it burns its fuel much faster, resulting in a shorter lifespan. Now, this heavenly behemoth, navigating a volume large enough to contain more than 1 billion of our suns, is approaching the end of its life cycle. When stars of such size reach their twilight years, they don't just vanish, they make a dramatic exit. A supernova explosion is beyond human understanding in terms of energy and brilliance. Such an event has the potential to overshadow an entire galaxy, illuminating vast regions of space. The last time Earth saw a supernova explosion this close was in 1604, before modern telescopes were developed. This event, known as the Kepler supernova, was the last supernova observed in our Milky Way galaxy. It remained visible to the naked eye for over 18 months, outshining every other star in the night sky, and was even visible during the day for several weeks. What secrets do these radiant remnants reveal to us? Ancient records from various civilizations, including Chinese and European astronomers, documented this new star. Interestingly, remnants of this explosion, in the form of an expanding debris cloud, can still be seen today with advanced telescopes, offering insights into the violent deaths of massive stars. While supernovae have been rare, imagine for a moment a stellar explosion so intense it rivals the brightness of a full moon, casting shadows on Earth at night and remaining visible during the day. The radiation from such an event could charge our atmosphere, potentially affecting satellite operations and even the climate. Betelgeuse, with its erratic dimming patterns, suggests it might be preparing for such a grand spectacle. Could we be on the verge of witnessing one of the universe's most dramatic events? Recently, astronomers made a startling discovery. Between October 2019 and mid-2023, Betelgeuse underwent a remarkable transformation that captured the attention of scientists and enthusiasts worldwide. Known as the Great Dimming, the star's brightness, which had been steady for centuries, began to decrease significantly. This sudden change was so noticeable that even casual stargazers observed it while comparing Betelgeuse to other stars in the Orion constellation. This implied that we might not be decades away from its supernova explosion but perhaps only a few years, or even less. By April 2023, observations reported that Betelgeuse had returned to its usual brightness level, convincing many that the period of irregularity had ended. In an unexpected twist, the following months saw Betelgeuse's brightness increase by an astonishing 50%. Such dramatic fluctuations, though typical for variable stars, were unusual for a star like Betelgeuse, which had predominantly shown predictable brightness cycles. The sudden and extreme surge in its brightness thrust the star back into the spotlight, sparking discussions about its future. What caused this abrupt change in brightness? Why did Betelgeuse, one of the most prominent stars in our night sky, suddenly throw a cosmic curveball? Stars are not just shining spots in our night sky. They are dynamic entities with life cycles, activities, and mysteries. For some celestial bodies, periodic brightness variations can be anticipated, much like Earth's seasonal rhythms. Throughout its lifetime, Betelgeuse maintained a consistent 400-day brightness cycle. However, the recent dimming defied its established behavior, challenging our understanding of celestial phenomena. Are we approaching a stellar revelation? While the exact reasons for Betelgeuse's irregularities remain under investigation, a compelling hypothesis has emerged. This theory, focusing on stellar activity and mass ejection, presents a fascinating scenario. Picture Betelgeuse as a giant cosmic volcano subtly erupting and ejecting vast amounts of its matter into space. Observations from the Hubble Space Telescope revealed that Betelgeuse had recently expelled a massive amount of surface material, an event 400 billion times more massive than typical solar eruptions, equivalent to several times the mass of our Moon. Such ejections can result in the formation of a dense dust cloud around the star, affecting its apparent brightness and making it temporarily more difficult to observe. As this dust began to dissipate or was pushed away by the force of the star's radiation pressure, the shroud lifted, explaining its return to normal brightness levels. These recent events suggest a star that is far from finished surprising us. Many speculate that Betelgeuse may be nearing the twilight of its life, a truly monumental event. A supernova, a spectacular explosion of energy capable of overshadowing an entire galaxy, occurs when there is a sudden change in a star's core. Such changes can happen if a star absorbs too much material from a neighboring star, or in Betelgeuse's case, when it exhausts its nuclear fuel, causing its mass to flow into the core, preparing for a catastrophic collapse. But what drives a massive star like Betelgeuse to its end? Stars like Betelgeuse begin their journey by burning hydrogen in their cores. This initial stage, known as the main sequence, lasts for millions of years and forms the foundation of a star's life. However, as stars run out of hydrogen, they expand and begin burning new fuel sources. In Betelgeuse's case, as hydrogen depletes, it starts to burn helium, leading to the formation of carbon and oxygen. This transition marks its evolution into a red giant. Over time, as helium continues to burn, the star undergoes further expansion and transitions into other burning phases, each marked by the fusion of progressively heavier elements. The larger the star, the faster these transitions occur due to the immense gravitational pressures at play. Eventually, when iron begins to form at the core, the process changes. Unlike lighter elements, iron does not release energy when fused, meaning the energy output is insufficient to counter the star's immense gravity. This leads to the star's core collapsing, followed by a massive rebound explosion, resulting in a supernova. So, is Betelgeuse close to the brink of collapse, or is it simply biding its time? Recent research from Japan's Tohoku University suggests that the star may currently be in its carbon-burning stage. Lead scientist Hideyuki Seo believes that the core could collapse a few decades after its carbon reserves are depleted. However, not all scientists agree. Contrasting studies from Hungary's Konkoly Observatory estimate that Betelgeuse is still in its earlier helium-burning phase. One thing that experts do agree on, despite these debates, is that Betelgeuse is destined to become the Milky Way's next supernova. However, pinpointing the timing of this event remains a wide-ranging guessing game, with predictions spanning from a few years to 100,000 years. Amid these scientific discussions and speculations about Betelgeuse's fate, one fact remains uncontested: the very nature of our observations. When we look toward the bright realm of stars, there is a subtle wonder we often overlook. This mystery is rooted in the fundamental nature of time and light in our vast universe. Stars and celestial bodies are so distant that their light takes an immense amount of time to reach us. For example, the speed of light, though a staggering 186,282 miles per second, 299,792 kilometers per second, has its limits. Consequently, The light from distant stars and galaxies takes time to traverse the enormity of space before it graces our sight. When observing Betelgeuse, you are essentially seeing a scene from 650 years ago. This means we are always experiencing the past, not the present, when gazing at the sky. Even if Betelgeuse were to undergo a supernova now, its light might not reach us for centuries. In fact, some have pondered whether Betelgeuse has already exploded, and we are simply waiting for its light to arrive. Alternatively, as some scientists predict, this moment may occur far in the future. How, then, can we truly witness the death of a star like Betelgeuse if we are constantly looking backward in time? This paradox highlights the intricate complexity and beauty of our universe. What makes this so striking is how human history will forever be intertwined with such extraordinary cosmic events. When Betelgeuse reaches the end of its life, we will not only witness the death of a star, but also a moment in time that harks back to ancient beginnings, when humanity first gazed up in awe. In that moment, we will learn something profound about our place in the universe. As we anticipate Betelgeuse's inevitable supernova, it serves as a reminder of the transient nature of the stars that illuminate our sky. Just as our sun will eventually reach its end, so too will this brilliant red giant. However, unlike our sun, which will end in a much calmer process, Betelgeuse's explosive finale promises to be a grand spectacle. The energy released in a supernova could be enough to trigger a chain of events that could impact the surrounding universe, sending shockwaves through space and potentially affecting nearby celestial bodies. While it is true that such an event could disrupt satellite communications or generate radiation capable of affecting life on Earth, astronomers agree that the likelihood of Betelgeuse's explosion having catastrophic consequences for our planet is very low. The distance between us and Betelgeuse, 650 light-years, is far enough that even a supernova would have only a mild effect on Earth and likely not directly harm life as we know it. Yet, the knowledge that we might witness a star's explosive death is significant. It reminds us that the universe is a dynamic, ever-changing place where even the brightest and most stable stars are subject to the same natural laws of birth, life, and eventual death. Moreover, it serves as a humbling reminder of our place in the cosmic timeline. If the supernova happens in our lifetime, we will have the rare opportunity to witness firsthand an event no human has ever seen before, offering us a glimpse into the sheer power and vastness of the universe beyond our wildest imagination. A cosmic event could unite humanity in a way few phenomena ever could. The night sky would be forever changed, with the once familiar red giant of Orion replaced by a dazzling, temporary beacon visible across the globe. Imagine the sense of wonder and unity as people from all walks of life, in every corner of the world, gaze up at the same radiant display. This shared experience would transcend borders, languages, and cultures, reminding us of our shared existence on this tiny blue planet within the vast expanse of space. The scientific implications would be profound. A supernova event in our cosmic neighborhood would offer an unprecedented opportunity to study the life cycle of massive stars and the processes involved in their explosive deaths. Observatories around the world would turn their instruments toward the remnants of Betelgeuse, gathering data that could reshape our understanding of stellar physics, nucleosynthesis, and the formation of heavy elements crucial for life. Supernovae are known to create elements heavier than iron, such as gold, uranium, and platinum, dispersing them into space where they become part of future star systems, planets, and even life itself. This means that the remnants of Betelgeuse's explosion could one day contribute to the formation of new celestial bodies. In a sense, its death would give rise to new beginnings, a cosmic rebirth that echoes the cyclical nature of the universe.